calculator out. Everybody ready to roll?
I'm ready to rock and roll.
And I'm praying that you're going to be just as well as yesterday.
Okay,
Okay, so we're on page 56. We're going to do final velocity after any displacement. Are you ready? So the first one says find the velocity of a stroll after the stroller in the sample problem E traveled 6.32. So we have to go back to the sample problem. The sample problem is on 55. So let's see if we know what our variables are. Are you ready? Did you do this? Do y'all have the answers? Okay. So, what is my velocity initial for question number 1?
0.
0 meters per second. Yes, ma'am. Thank you. What is my acceleration?
0.500 meters per second squared.
Perfect. What is my change in position?
4.75 meters.
Are we changing it though? In the question it says it's 6.32 now, right?
Okay.
Okay, you got it?
Yes, ma'am.
It's okay. You're looking at the other problem. Okay? And what is my velocity final?
2.8 meters per second.
Okay, let's figure out the equation first. What equation are we using for velocity final? Square root of volume initial square plus 2 times the acceleration change in position.
There's all kinds of
Yes.
ones to find velocity final.
It is a lot. And you look and see what you have. So what I'm going to do is I'm going to give you a minute. I want you to take your calculator. You're going to do the square root of 0 meters per second squared, right? Plus 2 times acceleration, which is 0.500 meters per second squared, times the change in position. Now, when we did this the other day, do we have to do this first? Together, right? Isn't that what we decided yesterday? We have to do these two together?
I haven't seen the formula with the square root.
Okay. Well, I'm giving you the formula. Put it in your calculator and let's see what we got. Now, what mode do we need to be in?
Radian.
Why radian, okay?
I'm not
And
sure.
normal. Let's do normal and radian. Because we're not trying to find any degrees. So we're going to do square root. We're going to do 0 squared. We're not squaring this though, right? Because that's my unit squared. And I'm going to times that by negative 6.32. Where's my bracket? What did you get? Okay. What did you get, Franklin? Okay. You broke yours down?
Yes, ma'am, because when I tried to do it the first time, I got like error.
I didn't. Because it's having a problem with that right there. You're perfect. You're doing great. Now figure out what you got to do to figure it out. May I tell you, easiest way is do the math first and square root last. I always do that. You're having an issue, do the math first, then do it. So what is 0 squared? 0. Okay. Okay, what'd you get?
3.412.
Did all the math first, and then I square root it at the end.
I mean, I put 0.500 minus 6.
Yes. And it's a negative.
Okay.
Exactly. Perfect. And this is the thing. You're looking at mine, and if you were writing it, if I was actually writing it my way of doing it in my calculator, I would have done it that way. So it's not confusing. Hunter, did you get it? I'll do that all year. It's fun. I'm having a great time. No, Jordan, did you get it?
Bro, mine is not working. Yeah, me too.
Yeah.
I'm tired of error coming up.
Well, don't do the zero square.
So
I did.
So just
I didn't
zero
do
plus 2, open bracket, 0.500, close bracket, open bracket, 6.32.
See, you didn't put a negative. That's what I was doing.
Well, so let me see if I put a negative, what happens?
Yeah, because it's a negative up there. That's
It's
a
a
square.
negative up there.
Mm-hmm.
So
But
you need not.
It's not negative.
So you don't need it.
Oh, it's not negative in the book.
Oh, it's not. Yeah, and I'm just gonna lie.
That makes a lot of
Yay!
that makes it.
Look at us. We're solving
Yay.
problems just like yesterday.
So it should be 2.51.
Yes.
You know, secret.
Okay, so sig fig rule, what is my answer though?
2.514.
Hold up.
2.8.
Okay.
1, 2, 3, right? 1, 2, 3 digits.
Okay, what was I looking at that had 4?
I don't know.
You can do it, man.
You got it.
You can do
That's what I was using different numbers.
Listen, I put a negative here. We're all good. Anything else with this question? We're good?
Okay, acceleration. Oh, never mind. Never mind.
You good?
Perfect.
Okay, cool. Hey. All right, so let's go to the next one. Number 2, we are rock stars already. So number 2 says, oh no, that's 3 problems in number 2. A car travels initially at a positive 7.0 meters per second acceleration uniformly at a rate of a positive 0.80 meters per second squared for a distance of 245 meters. What is the velocity at the end of the acceleration? Okay? What is our velocity initial?
7.0
What's my units?
meters per second.
Okay? What is my change in position?
245
245. What unit?
meters.
Y'all are getting so good at word problems. What's my average acceleration?
0.8.
It is 0.8. 80 miles.
We all agree? Okay? What are we looking for?
The final.
The final velocity. Guess what we're using again? The one we did in the first problem. Yay. Say, velocity final. By the way, on the test, I'm giving you the
Yeah,
equation.
how are we gonna like? Yeah, I
On
need
the
to find
test,
those.
I'm going to give you the equation that you need to use.
Thank you.
You're so
I love you.
I love you too. Okay,
You're
so then
such
that's
a
the
wonderful
square root, velocity initial squared, plus 2 times acceleration and a change in position, right? That's what we got.
So is it every time you define the final, you use square root, or just for these kind of problems?
These problems here, because we're square rooting it because we're having to change the formula, and to get something from squared, you have to do a square root
Square root.
to get it on the other side.
That makes
Does that make sense?
So for our test, we have to be able to identify and plug in.
Your thing is you have to find the variables. I'm going to give you the equation that you're going to use, and you just plug it in. And it's always a problem trying to plug it in though, right? Because you ain't got it right. Okay. So we got 7.0 meters per second squared. Why do I have a square here?
Why do you have a square there? Oh, you got two. Somebody's gotta catch yourself, you know?
I wish I can catch myself.
You don't put the square on the outside, do you?
I only put the square on the outside when it needs to be on the outside.
Yeah, on the outside.
When you put it in the calculator, you're going to do that.
Yeah, you do, if it's on the outside. So let's say, let's take this
It's
off.
21.
Let's do that and see what we get. Miss Sloan might have been in the middle of the night last night, decided, hey, because I thought, oh, wait a minute. No.
Oh, God.
Here it's
We
square.
forgot to,
That's what's here.
Oh.
See?
because you got our square.
Velocity initial squared.
Positive or negative? It's positive, right? So we get,
I'm just doing positive and negative because I'm not quite sure
Yeah,
yet,
not
but we will figure it out, yes. I'm just doing it because I'm not sure.
I mean, if it was a negative, it would
Don't-
turn out to be a positive anyway.
Don't let
wouldn't
it bother you. It's a positive.
Yes, ma'am. Gotcha.
All right, calculator's up. Let's see what we get.
21. Let's go. Really?
Really?
21. Where I go.
Okay.
So as long as the square is inside, you don't have to put it in the calculator, but if it's on the outside, you do.
Correct.
Okay, fine.
Did y'all square root?
Yes, ma'am.
You got 441 at first, and you square it.
Wait,
And what did you get?
I got 441.
21.0.
21.0 is
I just got
correct.
21.
21 is the correct answer
So
with the sig fig rule. And what is my units?
Meters.
Meters per
Per
second. Because what are we trying to find? Velocity, Miss Sloan. What is our units for velocity? Meters per second, Miss Sloan.
This one.
Everybody good so far?
Okay.
We're going.
it's certainly.
That is A. Now we get to go to B. So let's see what changes. It says, what is the velocity after it accelerates 125 meters? So, change in position is what?
It's 125
125 meters,
isn't it?
okay? So what other numbers do we need?
The same.
Velocity initial, 7.0 meters per second. We will also need to have our acceleration, which is 0.80 meters per second squared. Is there anything else we need?
No.
I don't think so. Okay,
We can use the same formula.
we're using the same
Let's
formula.
go.
Velocity final again. Square root of velocity initial squared plus 2 times acceleration, change in time, or change in position. Whoa. Okay? Plug in.
Ooh.
What did we get?
Is this the same problem we just did this time?
It is, except we changed 125 to from 245 to 125.
Okay. I'm with you.
What did we get?
I got this number.
All we thought.
I still got one.
I guess that would be
Can't be as
six.
slow as you are.
16.
I think I got it.
I got
16.8.
Here we go.
I got 16.8.
Here we go, Abby.
I got 15.72.
I
I got 15.
So, let's see.
Did you
2
do
digits,
6?
2 digits, and 3 digits. So which one are we gonna do?
So 2.
Mm.
2, 2,
The
and 3.
biggest, right? You always need the big,
2, always the smallest.
smallest.
So I got that too.
It would be 16.
That's what I said.
Oh my
Hey.
gosh.
2
Let's
Two.
go.
and 3.
Mhm.
Always will be the smallest. That is the most precise. Remember, think about it. The most precise is the one that is the closest to a whole number.
So 6.
Yeah.
Okay.
Okay, let's go to C. See what we're doing? C says, what is the velocity after accelerate? 67. So,
Same problem, just put 67.
so you could actually go up to your problem, right? And recall it
Yes, ma'am.
and just plug 67 in. What did we get?
Beautiful thing.
Yes, calculator's beautiful.
I got 10.1, but wouldn't it just like, it'd go down just to 10?
I got 12.49.
7?
What'd you get, Hayden?
Where?
I got 10.12 down.
Answer.
I got 12.
I got 12.4.
Where
I got
one.
12.4979984.
That's what I got.
Is that what y'all got?
Yes, ma'am.
Thank God.
I
So,
think it ain't the right.
what is my number?
You just do like 12.
Oh, 12.
What is my number?
12.
Well, yeah, but we're running to the what number?
It'll be 12.5.
2, 2, 2.
So 12.5.
2, 2, and
Oh.
2.
Oh,
12.
Well, because
Oh,
it's
it is. Yeah, I got
12.49,
12.
right?
I did
yes,
right.
right.
12.
Mhm.
We're getting there.
Okay. Now, can I tell you, these little babies down here
The tricky.
are the good ones. You will need to have them. I'm just taking your test out. You need to have these in your notes and you need to, like, I don't know, put it with different colors to say, this is what I need. What this is a little handy little thing that shows you initial velocity and it starts at rest, right? If it's going or if it's starting, right? These are the ones you're going to possibly use. Is everybody got that in their book? Did you take your little highlighter? And did you highlight it and put this here is where it has initial velocity. Well, let me get another color. This here is when it's at rest. These are some major formulas.
So I need to write that down.
Yeah, they need to be in your book.
Where?
Well, I put mine right after the problems we just got finished doing.
So we need to finish those other problems too. Like,
I'm good on that.
I put them on page 33. Now, this is what we're going to do. We're going to leave us enough space so that we have it, but we're gonna go ahead and go on to section 3. Okay?
That's free fall.
Yes, ma'am, it is. And it's only a couple of notes, and the equations are simple.
I thought it was really cool that it said that if like Earth didn't have the atmosphere, then a skydiver would fall at the same pace without a parachute as you would with a parachute.
Yeah. And I think it's interesting to see in a vacuum, these two items falling and how they're different and how they're the same. And I thought that was very interesting. Are you ready, Hayden? We're going to the next page.
Alright.
We're going to free fall. So in your textbook online, let's go on to page number 58. Everybody ready? Okay, so free fall from a vacuum. If you have an apple and a feather, the time is the same, but displacement is different. Please write that down. An apple and a feather in a vacuum falling. The time is the same, but the displacement does not remain constant. So it is not the same. Well, we're talking about a free fall. We're talking about an object that is being pulled to the earth because of gravity. What is the opposite force of that object as it is in free fall? So you have force of gravity on the box by the earth. What is the opposite force besides that?
Shouldn't somebody push them out?
There's something that's keeping it not to just, there is a force there. What is that force that is opposite of force gravity?
Inertia? Oh, no. It is all objects. then.
Atmosphere, pressure.
Pressure.
Force, normal.
Mhm.
There is a normal force, okay? You don't know this yet, but I'm introducing it here so that when we go into free body diagrams, you will remember, okay? So there's a force normal on the box by the air, okay? Now you have to agree that there is a force of resistance also depending on the size of the box, right? But I would have it beside the normal force, depending on how fast the box is falling, would depend on the force of friction, right? On the box by the air. So you have two things going on here. You got a normal force and you also have a friction force. You sitting at your desk right now, you have a gravitational force and you have a normal force. If you didn't have the normal force, what would be happening to you?
You would be pressed down.
You would
Under
go
my
through the
gravity.
floor, through the ground, through the earth until as far as you can go.
Yeah.
Does that make more sense?
And we didn't have gravity, we would
We
just
would
go
go
up.
straight up.
Exactly the same thing. So you have to think, you sitting still in your chair, there's a lot of forces that are acting, your muscles, your feet, your back, okay? But I do want to introduce that a little bit, just so that you don't think that gravity is the only thing at play when we're talking about something falling. Because even though there's no friction in that vacuum, there's still a normal force that's keeping it from not falling as fast, okay? Everybody good?
Yes, ma'am. Is that kind of like us sitting in a chair, like we're the gravity and the chair's the normal force that keeps us from just falling on the ground?
Yes. And when we're talking and we're getting ready to go into free body diagrams in the next couple weeks, when you're diagramming that, you're looking at one object. So it could be your foot. There's plenty of forces that are going on your foot, plenty of forces that are going on your knee, your butt. Every area has different force diagrams depending on what the object is that, or the system that you're doing. Okay? Anything else that you wrote in your notes that you thought was important?
I put that free falling bodies undergo a constant acceleration.
Yes. And acceleration is constant, upward and downward, right? No matter which way it goes.
And then the acceleration of an object of free fall to the surface of the earth is AG equals negative G equals negative 9.18 meters per second. I put that down too.
So the number for gravity is 9.8. Is that what we're using in this book? That is something that you need to circle, highlight, put an asterisk beside. If it doesn't tell you it's a different type of gravity force, it will be 9.8. On your test, it will be 9.8. If it doesn't tell you what gravity is, you're going to use that number. Let's turn now to page 61 in your book.
What was that number?
9.8
9.8.
meters per second squared. That is the units you're going to use. Yes, it's pouring down rain. Hallelujah. We need more rain.
Oh, yeah.
Okay, so let's look and see if we can dissect this sample problem. Okay? So it says a famous gateway of the West Arch in St. Louis, Missouri is about 192 meters tall at its highest point. Suppose Sally, the stunt woman, jumps off the top of the arch. If it takes Sally 6.4 to land on a safe pad at the base of the arch, what is her average acceleration? We've done velocity, right? Now it has a change in y. Remember what that was? What is that? Well, let's think about dry mix. Dry mix, change in y. Is that vertical or horizontal? Okay. And then it has a change in time. Pretty much everything you've seen before. Is there any problems or questions that you have based on how they did the calculation? Turn the page. Let's go to practice problem 1. Now we're going to do only a couple of these practice problems. This is how it is. I'm not expecting you to do all the practice problems. If you do 1 or 2 and you got it, you don't need to extra practice. I'm not going to require you to do more just to say you did it. I just want you to do as many as you have to get yourself to make sure you understand. So let's look at question number 1. A robot probe drops a camera off of a rim at 239 meters high cliff of Mars, where the free fall acceleration is negative 3.7 meters per second squared. So we are not using 9.8 here, are we? Because we're not on Earth, we're on Mars. So we need to use 3.7 meters per second squared. Find the velocity with which the camera hits the ground. So what do we have? I am on page number 62, question number 1.
Will they give us the free fall acceleration?
Okay?
Negative 3.7.
Yes. So my acceleration is not going to be 9.8. It's going to be a negative 3.7 meters per second squared, right?
Is that the actual one?
No. What else do we know?
That is 239 meters high.
So that is my change in y, right? What else do we know? Do we have velocity initial or velocity final?
We have velocity final at 0.
A robot probe drops a camera off the rim of a 239 meter high cliff at Mars where the free fall acceleration is negative 3.7 meters. Find the acceleration with which the camera hits the ground. Is that the final or is that the initial velocity?
I need to see that.
It hits the ground.
The final.
hits the ground. Okay, so we're gonna go with velocity final. So it's asking us that it has fallen and it hit the ground, right? What are we looking for? Go ahead.
So since it's falling, is that why 239 is negative?
Yes, because it's falling, right? In a negative direction if it's going up, and that's a good question. So, anything else we need? What are we looking for? Velocity what?
We're going, yeah.
Does it matter if it's velocity initial, velocity final? Are we going to do the same math? Okay, so let's say this is final and this is initial. It doesn't matter. Okay? It's one or the other, isn't it? So what is my formula? What we've been using.
Square root.
-2 plus 2a.
So what is my answer?
Where did we get the triangle Y from? What does that represent?
Change in y-axis. And when you do dry,
Oh, yeah, when the
Mix.
You explained that.
it's going to tell me it's going up and down, and it's falling from the top of the arch to the ground. Okay? Do the math and tell me what you get. Plug and chuck. You done? What did we get? What did we get? 42, what units? 42 meters per second, right?
Yes, ma'am.
Okay. Let's go to the next problem. B says, find the time required for it to hit the ground.
42 minutes per second.
Yeah, it's 42 even. So what are we looking now? We're looking for what?
Find the time required for it to hit the ground.
We're looking for a change.
Change.
So now we're looking for change in time, right?
Yes, ma'am.
So our velocity initial, we just said was what again? 42 meters per second. And now what we're trying to do is we're trying to find the time required. So we're looking for a change in time,
Yes, ma'am.
okay? Well, what are we going to do?
Yeah, I don't know.
Use another formula.
That was what we've done before with change in time, isn't it?
Yes, ma'am.
Okay. We're going to do this one and two and see if you feel confident because these are super easy. And they're all the same, so. What did we get?
I did too. 11.3.
So it would be 11 seconds. Yes, perfect. Do you feel like you need to do one more, or are you good with this? Okay, we'll do another one.
So these.
Do another one.
These.
Okay?
A flower pot falls.
Yes, it does. A flower pot falls from the windowsill at 25 meters above the sidewalk. How fast is the flower pot moving when it strikes the ground? Okay?
So we use
It's going,
our
initial is
9.81.
Is our acceleration?
No, so it's 9.81.
And it's a negative because it's falling, right?
Mhm.
Okay?
yeah, okay,
It's falling, so it has to be a negative. 9.8 meters per second is going in the downward direction. All right, what else do we have?
they gave us that number, right, to plug in.
Well, we know that, yes.
Change of y is negative 25.0 meters.
Okay?
And one of our velocities is going to be 0 meters per second.
Okay, so it's-
Initial, wasn't it?
Yeah,
It's
I
coming
love
from our window.
it. Initials, because it is on the windowsill and it's getting ready to fall.
Yes, ma'am.
Okay? And what are we looking for? Final velocity
Which is
Yeah,
final velocity.
equals square root of the square plus 2a change in y. What do we get?
22.14
Mm-hmm, that's what I got.
for 22 seconds.
22.1 meters per second. Yes, sir.
Yes, ma'am.
I think the hard ones was the other day, not this one.
They don't.
Let's look at B. What are we looking for now? Time again. So how are we doing time? Change in time equals velocity final minus velocity initial over acceleration or average acceleration. So 22.1 meters per second. We're going to subtract 0 meters per second squared. We're going to divide that by 9.81 meters per second. And that is going to give us seconds, like we're supposed to have. So what is our answer?
Hold on one second.
2.25 seconds.
Yes, ma'am, 2.25 seconds, perfect.
I have a question.
Yes, ma'am.
So we put negative 9.81 for our acceleration.
Yes, sir. Yes, ma'am, sorry.
So the A at the bottom, we would just take away the negative and just put 9.81
That's what I did.
instead of the negative 9.81.
He kept coming in as error for me.
Yes,
Okay.
Wait, what?
because you know a negative divided by a negative, right? There you go. I understand in the calculator it won't work. You know it though. I personally, even though it's a positive or a negative, I just took the negative sign off for myself when I did the calculation. So I wouldn't get an error because I know that the calculator does not like it.
Yes, sir. I just know there can't be negative times. So I was just.
Exactly. Perfect. And I do it that way just so I know when I start doing that, it just doesn't mess me up.
So it was a negative to the answer, right?
This here was a negative, yes.
Yes, ma'am.
Okay, everybody good?
Yes, sir.
Do you feel good? Bailey, what question do you have and what page? Do you want to go over before I give you the test?
Just Page 51, question number 4.
Okay.
Car enters a freeway with a speed of 6.4 meters per second, accelerates uniformly for 3.2 kilometers into 3.5 minutes. How fast in minutes and seconds is the car driving after time? Is that the question?
Yes, ma'am.
Section, chapter 2, section
Page 51.
2, chapter 2. Number. So what is the first thing that we would do, Bailey? I don't even know if I did it.
I think it was just late when I was reading it, because now it's making sense. So you would figure out what each of your things are. So
Yes, ma'am.
Velocity initial
Let's do it real quick.
6.4 meters per second.
Okay, velocity initial is 6.4 meters per second. Yes, ma'am.
And the change in position is 3.2 kilometers. Isn't it? And then the change in time is 3.5 minutes.
Mm-hmm.
And so are we trying to find velocity final? Is that what it's asking for?
How fast is the car moving after this time? Velocity final. Yes. We are. So what formula are we going to use to get velocity final?
The square one? No.
1/2 of, wait, I gotta deconstruct it.
Yes, ma'am. I'll wait. Well, I'll wait. I'm going to look at mine.
What page were you on? What page is it?
We're on page 51, sir.
I'm not sure if it's right, but it'd be 2 times the change in position over the change in time minus velocity initial.
Try that equation.
Okay. So what we do with the velocity initial.
We don't need it.
Okay.
Not all the time do we need every single thing, right? Do we need a velocity initial? No. We need a velocity final. Does it matter what it started with? Nope. We have a change in position, which is x, and change in time. So it would be 2 times 3.2 kilometers over 3.5 meters.
I got 1.8 meters per second.
So 2.
Now, there's something else that we have to do though, right? What else do we have to do?
The kilometer.
First of all, kilometers can't be in kilometers, right?
Yes, ma'am.
So we're gonna change it to what?
You wanna change it to meters?
Meters, okay? So to be able to do that, kilograms are on the bottom, meters are on the top. How many meters are in a kilometer?
10 to the -3.
From our chart, right?
Mhm.
Okay? Down here, is there anything we need to do down here? Because we're trying to find velocity final, it has to be in meters per second, right? What else we need to do? Right? Because that's in minutes. We got to change it to 60 seconds. Let's do our calculator. Apple White equal. 2 times 3.2 times and 3. What'd you get? At 24. What that would equal? What would this equal? 3.5 times 60.
210.
Mm-hmm.
Yeah.
Here, so 2 times. Let's do it. 2, open bracket, 3.2 times 10, carry 3. Open bracket. 20. 21. Close down 20. 320. What'd you get?
I didn't get 320. Sorry, I don't have,
3.5 times 60. 210. Oh, dang. I can't do stuff. I'm sorry, it's my fault.
okay.
I am so sorry. I got 30.
Me too.
Yep, that's the answer. Took me a minute. Questions on what's the other page, Bailey, that you need? Anything?
I think I'm good now after everything you said today.
Okay.
Because I was worried about a problem that I had finished but understood.
Mm-hmm.
And I just wanted to, but you said that as long as we understand it, just turn in what we've done. So it's good.
All right, is everybody ready?
I did.
Okay. I'm giving you the paper test, but then I'm going to also assign it online. You will have to take the paper test and put the answers online because I want you to see how to do it because it's kind of tricky. I'm going to come here and see if I can assign it. Now, right now it's 3 o'clock. You have 30 minutes. I truly believe that you probably can finish it by then.
All of it?
Yes, all of that.
I definitely.